Today we are talking about Program Evaluation and Review Technique, or PERT. PERT is a similar tool for network analysis with CPM. CPM or critical path method and PERT can be used hand in hand for any project development. Okay, so in network analysis you have mainly these two, CPM and PERT. But these two, while they can be used hand in hand, these two have significant changes or differences. For example, CPM relies on more of like a deterministic approach. Duration of activities, duration of projects, details of activities, all will be deterministic, predetermined, and we are sure that that duration will not be changed at the time of implementation. But in case of PERT, it is more of a probabilistic approach. As you know, all the durations and all the particulars will be probabilistic, will be decided on that mathematical, based on that mathematical study. We'll be studying or we'll be relying on the most probability curves and with respect to two parameters, two extremes of this particular probability curve. Okay, so probabilistic approach for PERT and deterministic approach for CPM. Okay, and another difference, CPM was based on activity, or we can say critical path method was more activity oriented. Most of the things were based on activities. Okay, but in PERT it is more of event oriented. More things will be talked about events, and details will be important more to event compared to CPM. Okay, and CPM will be used more for repeated projects. Where there will not be any surprises. That's why we are using deterministic approach. If suppose you want to produce a car, or you want to market a car, or if you want to open a hotel, or you want to construct a building, a routine building, single story building, all those things we have a particular procedure and we can just follow that procedure up. That's why we use CPM. But in case of PERT, we will be using for research projects or unique projects. For example, space project, or any research, medical research project, or a group of people studying a new thing. Okay, and suppose a new type of building is to be invented. Okay, these all projects will be relying more on PERT. That's why we rely on probabilistic approach, because it is filled with surprises. It can be very easy to do sometimes, but it can be very hard to complete. Okay, so these are the significant, only three, we are just taking three significant differences of PERT and CPM. And as you know, in CPM we had one event I, an activity, for example A, and another event, head event and tail event, right? And we had a single duration. TIJ was duration of activity. It was about 3 days, 4 days, 7 days, 11 weeks, etc. Okay, but in case of PERT, we are having a tail event, activity A, and we are having a head event J, but instead of having a single Tij, we have 3 sets of time parameters. Those are TO, TM and TP. So we will be expressing an activity like this. There will be three numerical values. Okay, and we will come to those. TO is optimistic time. Okay, optimistic time is if you are considering an activity and everything goes as planned, everything was perfect, nothing changed from our plan, then TO will be our duration. So obviously we will be planning for maximum least duration for an activity. So TO will be the minimum value, optimistic time. If everything goes ideal, optimistic time. And TP, that is the opposite, pessimistic time. If everything goes wrong, there a natural calamity happens, a work strike happens, there is a workman defect, everything, then it will be TP. Okay, the can get elongated. For example, if T0 can be 3 days, TM is 5 days and TP is 8 days. If everything goes ideal, it can get completed by 3 days. If everything goes wrong, at least we can complete it by 8 days. We have a guarantee. Okay, that is 8 days. And last one, TM, that is most likely time, that is 5 times. If you are doing this activity in repeated times, most number of times you can get this activity completed by 5 days. Okay, that's based on probability approach, probability studies. So you have a optimistic approach, optimistic time, a pessimistic time, and most likely time, where you can get this particular activity A can complete it most probably. Okay, if you do this activity 10 times, 8 times or 7 times, you can get completed in 5 days. Okay, and while talking about probability curve, if you plot this as a curve, time as x-axis and probability as y-axis, this will be the curve, and as you know, this will be optimistic time, the least time where there will be lesser frequency, and this will be obviously TP, lesser frequency with maximum possible magnitude, and this will be what? TM. Okay, so I hope you understood. Most probably this you can express 3, 5, 8 or any value, 6, 10, 14. 10 is the most likely time, 14 is the pessimistic, and 6 is the optimistic. Okay, so when you have these such 3 values, time parameters for an activity, it will get complicated, right? You want to have a single value. So to calculate critical path, or to calculate slack, or to calculate TE and TL values, you can calculate in PERT also. So for that calculation, you need to have a single value to substitute Tij in CEPM. Okay, so you can calculate a singular value using these 3 values, and that value is known as expected mean time, that is TE. Okay, so this TE is the one that you will be calculated from these 3 values from this equation. TO plus 4 into Tm most likely period will be multiplied with 4 plus Tp divided by 1, 2 plus 4, 6. Okay, so T is equal to To plus 4 Tm plus Tp divided by 6. There are 6 singular parameters. Okay, and this can be used, T can be used instead of Tij for calculations slack, for calculation of critical path method, T, TL values, etc. Okay, so T, you have T, and for any probabilistic study you will be having, for a sample of activities or data, numerical data, you will be having standard deviation or sigma, and sigma will be equal to Tp, the maximum value, Tp minus To, the minimum value, divided by how many you had for at the numerator 6, right? The same numerator 6. This is the standard deviation of a particular activity, and from if you have standard deviation you can find variance. These are all basic mathematics, right? That variance is sigma square, standard deviation square, that is Tp minus T0 whole square divided by 6 square, 36. Okay, I hope it's clear. We have 3 equations and you can calculate all these things using 3 parameters for each activity. If this is a bigger network, you can calculate these 3 parameters for all activities. If you have 14 activities in a network, you can calculate 14 T's, 14 standard deviations, 14 variances. Okay, and if you want to calculate the T or more expected mean time of a project, T of a project, these are all T of a single activity. If you want to calculate T of a project, either you can calculate or you can add all the T values of activities I to N. You can calculate each T values and you can add up all the T values to get T of a or most mean time of that particular project or that particular network. Okay, or you can calculate it by this equation, T of project is equal to sigma T0, all the T0 values, all the optimistic time values, plus sigma for Tm plus sigma Tp divided by 6. Simple, isn't it? Either you can calculate by taking the sum of all T values, or you can take the sum of all these 3 parameters of all activities, then calculate T of project. Okay, so I hope it's clear. Now we will move on to a question. So this is the question. You have to find the expected time of activities and critical path. Okay, and this was the question. This is our answer. We need to draw this table, need to number in all the activities, and you just need to take all these TO, TM, TP values from this network. Okay, so you will be given this network only. Okay, and activity 1, 2, 1, 2, 3, 1, 4, 3, 6, 8, 1, 3, 2, 3, 4, etc. You can just take these numbers into this table and you know the equation. T can be found out by T is equal to TO plus 4Tm plus TP divided by 6. That's it. Okay, so this T 1, 2 will be equal to 1 plus 4 into 2 plus 3 divided by 6. that will be equal to 2, and T14 is equal to 3 plus 4 into 6 plus 8 divided by 6 will be equal to 5.8. Okay. So similarly you can complete all these values. Okay. So values will be, so these are the TE values of all activities. Okay. So now you need to find the critical path. So now for the time being you can take these values and write it on these respective activities. 2 is of 1 to activity, 5.8 was for 1.4, 3 was for 1 to 3, 2, 5, 5.16, 4, 7, 17.6, 3, 4, 4, 3, 6, 5, 5, 7, 6, 6, 7, 7, and 2, 4, 6. Okay. So you have all the TE values. Okay. Then we'll just rub off this table. Okay. And to calculate, so you have the expected time. If you want to calculate the total expected time, you can just add all these values from the table itself. Okay. 2 plus 6 plus 5.16 plus 6 plus 17.7 plus 7 plus 4 plus 5 plus 1.8 plus 3. Okay. So that will give you expected time of project if it is asked specifically. Okay. So in our question, next one is critical path. So for calculating critical path, you can move by 2 means. First one, you can calculate with respect to each path. You can enumerate the number of paths from 1 to 7 and you can add up the expected time values. For example, from 1 to 7 or the completion of this network, you can have 4 paths. The paths are 1, 2, 5, 7. You can come right around this, or next one, 1, 2, 4, 7. Right. Next one, 1, 4, 7. Next one, 1, 3, 4, 7. Last one, 1, 3, 6, 7. Okay. And for each path you can find out TE. For 1, 2, 5, 7, 1, 2 was TE of 1, 2 path was 2 plus 2, 5 was 5.16 plus 5, 7 was 6. That's equal to 8, 7 plus 8, 7 plus 6, 13.16. Okay. Similarly, you can calculate all these values, right? So 1, 2, 2 plus 6 plus 17.6, that's equal to 25.6. Right. Next one, 5.8 plus 17.6, that is 17 plus 6, 23, 23.4. Next one, 1, 3, 3 plus 4 plus 17.6, that will be equal to 24.6. Last one, 3 plus 5 plus 7, that is 8 plus 7, 50. So you have 13.16, 25.6, 23.4 and 24.6, and critical path will be path with maximum t, that is 1, 2, 4, 7. 1, 2, 4, 7. That is 1, 2, 4, 7. This is the critical path, and the priorities for above all the activities will be given to 1, 2, 4, 7 activities. Okay. This is one way for finding critical path from PERT method, or we can calculate or find our critical path by our old method by calculating all the t values. We have the t values. Using t values, we take it as Tij values in CEPM. Find, considering t values as similar to Tij, find Pe and PL values. You know how it is, right? Third one, using T and PL values, calculate slack values for each event, and at the end, you know how it ends. Critical path will be the path with minimum or 0 slack. If you do this for this network, you will get this way itself, this path itself. Okay, so this is the one we have referred in our previous videos, calculation of T and TL, and from T and TL you can just calculate slack. Slack is just the difference of TL minus T slack, and the path tracing the minimum of this slack value. Similar, we took maximum T here, instead we will be taking minimum slack value, and that path will be critical path. Okay, I hope it's clear. So you can find in PERT, you can find T value using an equation. We can make use of these three TO, TP, TM values. Then you can calculate the total expected time of the project by adding all those up, and you can find the critical path by two methods. By one, after finding all the paths for completion of the projects and calculating all the TE for each path, and second one, our old method, find slack of each events, then finding critical path with 0 or minimum slack. Okay, I hope it's clear. Thank you. So this is the practice problem. You are asked expected completion time, variance and critical path of the project given below with T0, TO, TL instead of TM and TP in days. Okay, so you just need to find out TE of each activities, variance of each activities, and critical path by any of the methods. And while finding critical path, you will get, for example, 1, 3, 5, 7 like we did last time, moments before, and you can find the minimum required time of the project by adding T values of each activities
For example, 1 to 3, 3 to 5, 5 to 7. Okay, so you can find that also. It is not asked right now. If asked, you can do it. Okay, thank you.